Let's take a second to talk about metal-nonmetal bonding. These are what we call salts, mostly. So, for example, you're familiar with sodium chloride, because that's table salt. That's when we say you're going to put salt on your food. What we're talking about is sodium chloride, and that is the chemical formula for sodium chloride. And the way we know that is if we look here, sodium, if it's going to pretend to be like neon, it needs to lose one electron. Electrons are negative. Losing a negative electron puts it in the 1+ state. And so a sodium wants to be 1+. A chlorine wants to be 1-. It wants to gain one electron. Gaining an electron puts it in a negative 1- state. The deal is that whenever we make these sets, the total charge has to add up to 0. And in fact, the total charge of everything you've ever touched in your life is 0. It is true that things can pick up small amounts of charge like static electricity, or we could talk about more extreme situations as lightning's about to strike or electricity in circuits. But even then, it's close to neutral. But I always say anything that doesn't shock you has a charge of 0. And so certainly if I touch table salt, it's not going to shock me. So the total charge has to be 0. That means for every sodium atom, there has to be a chlorine atom. And that's actually how salts go together. There's electrostatic forces. Once we have a positive thing and a negative thing, like opposite poles of a magnet, they want to stick together. It is not really one sodium atom stuck to one chlorine atom. Sodium atoms are pretty small compared to chlorine atoms. And, they're in some very, very, very long extending matrix of sodium atoms and chlorine atoms going on and on and on virtually forever, because there would be a very large number of atoms even in a small crystal of salt. And so you can imagine this extending forever. But the point being, in the chemical formula, we draw one of each because that's the proper ratio. For every sodium atom, there's a chlorine atom. And this type of thing can go on. If we want to talk about, for example, lithium sulfide, that's a fun compound to make in the lab. Lithium is bound to a nonmetal. It's a metal bound to a nonmetal, and so it's going to have a charge. That would be a salt by definition. Lithium wants to be 1+. And I put that superscript 1+ there only when lithium's written by itself to say it's in the 1+ state. Sulfur wants to be 2-. For these things to come together and have a total charge of 0, I'm going to need 1 extra lithium. And that's right. Everything inside that box sums up to 0. And so the chemical formula for lithium sulfide is Li with a subscript 2, S, lithium sulfide. And that would be the salt. We can do more examples. Aluminum chloride. This is an important combination because it's a precipitate in a lot of reactions. It falls out of reactions. I think that's right. Maybe I'm wrong. I think that is right. I don't think that's a soluble salt. Oh no, that's silver chloride. Either way, aluminum chloride. I'm going to post this video even with the mistakes. Aluminum chloride, we want to write this, but what we don't know is what number goes there and what number goes there. And so we have to, again, break it down. Aluminum wants to be in the 3+ state. 1, 2, 3 because it's going to pretend to be like neon. Sorry, it needs an Al3+. And chloride right there wants to be in the 1- state. So Cl- or 1-, you can put the 1 there or not. And here again, we recognize if we add these up, that does not add up to 0. Aluminum chloride is a real salt. You can touch it with your hands. And so everything has to add up to 0. And so we need more chlorides. And again, now everything inside of that box adds up to 0. And we can write that the chemical formula, oops, I'm writing outside the box, outside of the screen. We can write that the chemical formula for aluminum chloride is 1 aluminum and 3 chlorines.